Okay, so the final video looking at drawing techniques. I'm sure you can get some things like this online, but if you want me to explain it to you, I'm very happy to. Do not be confused that there is any relationship between these two drawings. There is not. They are completely different drawings, okay? So I don't want you to be confused in any way on that. Right, let's have a look at the drawing. What can we glean from this? Well, it looks to me as if we've got some sort of hole in it. Or some sort of cylinder. Given that we can't see a cylinder on the front projection, would suggest that this is a negative extrusion. This is a void, a circular void, a cylindrical void. What else have we got? We've got this as well, haven't we? This is an odd. This is some sort of slope, and given it's a slope, look, it finishes here and here. So that plane that we've got there. Well, I'm just gonna shade that in. That plane I believe to be sloped because it relates to that one, and of course the one above is also sloped because these are the same planes. Okay, that's the front view, that's the top view. Okay, so it looks to me like there is a slope which goes up, an angle that goes up, and then on the top, on the plans, on the top of the face, there is some sort of L shape, B shape, whatever you want to call it, here, I think. There's also some sort of void here, like it's got a bottom to it, it's got a base, and then it's got this part which overhangs, but this section here is a void. So that's got to bear that in mind as well. Right, so what are we going to do? Start off by rationalizing. What are we going to say? Well, I reckon 4 by 6. Do you reckon? I reckon that's about right. So I think I'm going to give this face here a value of 4, and then yes, so that would be going to the top, and that would be going to the bottom, and then I'm going to give this face here a value of 3 and 3. So the total value of that face would be 6. The height, I think a value of 3, which works quite nicely. And I think we'll give these a value of 0.5 and 0.5, which makes me feel like I should use a scale of double so that I can use the isometric paper. So let's start off by choosing the common point, which is this point here and this point here. Let's start by drawing my rectangle, my cuboid. I'm going to come over. I'm coming over a little bit in this direction because this face here is longer than that face there, and therefore I'm not going to go into the middle. Oh, you can't see, can you? I'm not going to go into the middle. I'm going to go slightly to one side. So I'm not going to go in the middle here. I'm going to come across. I'm going to put a common point in there, and that refers to my common point there. I'm then going to go up 3, but I'm going to go up 6 triangles here because I'm doubling. All right, so there we go. That's the first bit. I'm then going to come across. We said 4. Of course, that distance there is also that distance there because they are the same distances. They are the same thing. Do you remember what we did before? Is we put that line so that, well, to be honest with you, this hasn't been done correctly. That drawing is not correct because this distance here is different to that distance there. And so we can't use that 45 degrees, unfortunately. However, let's keep on going. We put a line which is 6 in. I'm going to put a line now which is 4. So 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to draw in the face of that rectangle because I'm going to start off with a rectangle. I'm going to move this just so it's a bit easier for me. I've then got a face which is 6. That's going to be 12 because I'm using 2 units or 2 triangular units, aren't I? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. doing it on the top and bottom is quite a nice way of just checking that you've got both sides correct, because quite often it's quite hard and you might miss a unit or pick up a unit. All right, and then so now you can see we have my shape. Brilliant. So what do I know? Well, I'm believing that all of this sort of chair shape here is on the front face. This shape, I'm going to shade it for you. That there, I believe that's on the front face. And it's got a unit of 1 by 3. So I'm going to come up 1. I'm going to go back 3, which of course is 6. And then it goes up. So I'm going to put that in. I'm going to put this in. And then towards the back, it's got 3, so 2, 4, 6. And that's when we've got the half units. But of course, the half units times 2 are 1 unit. So this has worked out quite well for me. And that will go back 2 units. So 1, 2, 3, 4. 1, 2, 3, 4. So that there is my face. And you can see that. Oh no, I can't believe it. You couldn't see. I'm sorry about that. There we go. So what I've done is I've drawn this in just to go through that 1 unit up there, which is of course 2. And then I've gone across 6 triangles, 3 units. And then I've gone up 4 triangles, 2 units, and I've gone across another 3, 6 triangles. And then this is quite convenient here because a half unit that I put in here becomes 1 triangle. Hope that all makes sense. Right, so I've now drawn in this shape that we were looking at before. Let's have a look at this then. Well, it looks to me this side section, so I think if I'm looking at that, I've got all of these dotted lines here, but these refer to the hidden line, which is this and this. They've also got these dotted lines here and here, and here and here, here and here, and that refers to this hole, which goes all the way through. And so really, the only thing I've got on the face of the cuboid is this shape here. And so I know that that point is that point, which is this point here. And so all I've got to do is work out where the top of this angled section is going to be located. And we know from the plan that that's going to be 1 unit. So I'm going to come back 2 triangles and I'm going to put in that line. Brilliant, that's good. Now, exactly the same thing should be happening here. And so I can draw a line going back, I can run back here. And now what I can do is I can join up those 2. And what we can begin to see is the shape. And it is of no coincidence that the shape that is being produced up here is exactly the same as the shape which is here. So the last thing I've really got to do is put in that negative cylinder, and that negative cylinder is, well, what do you think? It's probably about half. It's probably about half and half, isn't it? And it's probably about 1. Is that right? About that? I think that works. I think it does. I think it occupies that area there, which I've just drawn out. So what I need to do is now I've drawn it in. And now what I would do is I would drop down this distance, that, and put another one in. It's a little bit eggy. And so we can now see that negative cylinder. What I've not done is the return from this corner, which I'm now going to put in. I'm also going to just project this down. There we go. And that is our isometric drawing of the shape above. which, to be honest with you, once you break it down into form, once you rationalize it and you get some proportions, it's not that hard to do. Just look out for those dotted lines that can be confusing. They are to symbolize obscured areas which can't be seen. Okay, so for example, we couldn't see this negative cylinder because this was in the way on the side projection, and yet they were still within the drawing, and that allowed me to know that, okay, I have got a negative cylinder on the top overhang and the bottom. Right, I hope that helps, and it is of some use.